You can see this right side that 5 types of d orbitals. That means for L is equal to 2, then that means the azimuthal quantum number when it is 2, then the orbital is known as d orbital. And in that case, the minimum value of the principal quantum number should be 3. We know when the principal quantum number is 3, then azimuthal quantum number will be 2. That means L is equal to n minus 1 when n is the quantum number. This we understood from our previous class. So when L is equal to 2, then the ML value will be -2, -1, 0, +1 and +2. That means for azimuthal quantum number 2, there are the 5 magnetic quantum numbers. And so there will be the 5 d orbitals because ML value is 5. 1, 2, 3, 4, 5. And in that case, the boundary surface diagrams is in the right side figures. So we'll go now in details of these d orbitals. These 5 d orbitals, these are designated as dxy, dyz, dxz, and dx square minus y square, and dz square. So here all these 4, that means xy, yz, xz, and x square minus y square, these all d orbitals are similar in shapes to each other. You can see that all are similar. dxy, dyz, dxz, and dx square y square is shape. All are same. But for dz square, for this orbital, that means 5th one, is different from others. But one thing we have to remember that in case of energy, for all 5 d orbitals, the energy is equivalent. The d orbitals for which the n is greater than 3, that means 4d, 5d, etc., and then the shapes similar to 3d orbitals. That means when the principal quantum number increased, then the shapes of d orbitals are all similar. That means for 3d orbitals, whatever the shapes is there, for 4d, 5d, etc., their orbitals also shape is same, but it differs in energy and size. We know with the increasing of the principal quantum number, that size also will increase and energy also will be increased. And besides the radial nodes, regarding nodes, I already discussed in my previous class, because nodes is called where the probability density function is 0. I think class number 35, I have discussed on it. And besides the radial nodes, the probability density functions for the NP, that means p orbitals and d orbitals, also are 0 at the plane and passing through the nucleus, which is the origin. For example, the PZ orbitals. PZ orbitals, what is the plane? XY plane. And it is called the nodal plane. And for the XY orbitals, there are the two nodal planes. One passing through the origin and bisecting the XY plane containing Z axis. We have to remember this, what is the radial nodes and what is the probability density functions. I already discussed in my previous class. Please go through the previous class and understand this very clearly. So that means the nodal plane related, and in that case these are called the angular nodes, and the number of the angular nodes are given by the L. L, you know that this is the angular quantum numbers, its value is angular quantum numbers, and that is the one angular nodes for p orbitals. Because p orbitals, we know L is equal to 1, and so p orbital has only one angular nodes. And two angular nodes for the d orbitals. Why? Because for the d orbitals, L is equal to 2, azimuthal quantum number 2. So that means two numbers, angular nodes, will be present in d orbitals, and so on. So the total number of nodes, which is given by the n minus 1, n means always it is the principal quantum number. What does it mean? It means the sum of L angular nodes and n minus L minus 1 radial nodes. So if you sum this L plus n minus L minus 1, then ultimately it will come n minus 1.